So we're going to talk about polynomials today, and we're going to introduce them with this contraption that I have up here at the top. So I'm looking at 3x cubed minus 5x squared plus 0.2x minus 1/2. This is a little bit more complicated than most of the polynomials we'll be looking at in this class, but I think it's instructive. So we're going to talk about the parts of a polynomial. The terms are separated by addition, and we can rewrite this polynomial with addition by recognizing that subtraction is the addition of a negative. And so when I'm looking at the terms of the polynomial, I'm going to get 3x cubed minus 5x squared, 0.2x, and then negative 1/2. The terms are each part, but the minus signs go with, okay, because the subtraction is the addition of a negative and terms are separated by addition only. The coefficients of a polynomial are the numbers in front of the variable terms. So in this case, I have 3, -5, and a 0.2. The constant or the constant term is the term without a variable. And in this case, I have negative 1/2. For the most part in this class, we're only going to see fractions, basic decimals, and integers in front of our variable terms. But in theory, things like pi and the square root of 2 can be coefficients or constants. And then finally, the degree of the polynomial is 3, and that's the highest exponent. And I want to take a little bit of time to point out that this polynomial is written where I have the cubed term first, the squared term second, then a linear term third, and the constant term fourth. This is in descending order because my exponents are descending. If I were to rearrange it, the 1/2 would be out front, and the x cubed would be out at the end, and it would be in ascending order. We can think about this last term to be x to the 0 power because anything to the 0 power is 1, but we typically don't write that. All right, so with polynomials, we can do a bunch of things, and in the future videos, we're going to learn how to add, subtract, multiply them, solve polynomial equations, factor them, all kinds of good stuff. But in this one, let's talk about some basics, combining like terms. So if I have, for example, 5x squared minus 2x plus 3x squared plus 7x minus 8. This is a polynomial that has 1, 2, 3, 4, 5 terms, but it can be simplified, and I can simplify it by combining like terms. What I'm going to want to do is I'm going to want to rewrite it, and I'm running out of room, so I took a lot of space to write this. We don't always have to write it this way, but this helps me keep track of my signs. And since addition commutes, I can move things around a lot easier. But most people are going to do a lot of this in their head, but this is the details of how it works. What I'm going to do is I'm going to look at subtraction is the addition of a negative. So I'm going to rewrite the polynomial with that in mind. Wherever I see minus, I'm going to write plus a negative. So 5x squared plus a negative 2x plus 3x squared. Good thing I'm reviewing. Plus 7x and minus 8. Or plus a negative 8. And I'm going to rewrite it where I have my squared terms next to each other and my linear terms next to each other. The constant term doesn't have any friends, so it's just plus negative 8 hanging out by itself. And technically speaking, we're using the distributive law to combine my like terms. If you think about 5 apples and 3 apples, I have 8 apples, right? So I'm going to use a distributive law to factor out that x squared, and I'm adding my coefficients. And then when I combine what's inside the parentheses, I'm going to get 8x squared plus 5x minus 8. Again, a lot of folks are going to do this in their head. They're going to look up at the original polynomial and say, well, I have x squared, 5x squared, and a 3x squared. 5 plus 3 is 8. Negative 2 plus 7 is going to be a positive 5. So I have 5x. And then negative 8 is just hanging out by itself, so it's carried down. And a lot of this does, again, happen in the head for a lot of folks. But if you need to write it down or if you need to justify any of your steps, this is how that works. And we're also going to talk about how to evaluate. I'm looking at x squared minus 2x plus 3, and I'm asked to evaluate it when x is negative 4. This is plug and chug. We're going to plug in negative 4 for x. We're going to follow the order of operations. So what we're going to do, I like to use parentheses whenever I'm plugging in a value for a variable or substituting a value for a variable. That allows me to keep track of my signs. I am squaring negative 4. Negative 4 times negative 4 is a positive 16. Negative 2 times negative 4 is a positive 8. And 16 plus 8 is 24. 24 plus 3 is 27. So if we're asked to evaluate a polynomial expression, we're just taking that number and plugging it in and following the order of operations. Sometimes you might see this in the terms of polynomial functions. So if I have p of x is equal to 3x squared plus x minus 2, and I'm asked to find p of 5, it's a plug and chug again. I didn't need a parenthesis there. I don't know why I put that. And I follow the order of operations, and that allows me to get 78. So p of 5 in this case is 78. One last thing. We're going to see this later on, but I'm going to talk about it now. When we're talking about the opposite of a polynomial, that's a minus sign on the outside. And what we need to do is we need to distribute that negative value. So that changes all the signs inside. So I get a negative x squared minus 5x plus 4 in this case. And in the future, you're going to see this used to rewrite the order of a polynomial when you have subtraction involved. So example, I have 4 minus x squared, and I want to rewrite that with the x squared out front. If I want it in descending order, I can think about that as negative x squared plus 4, or we're going to use this a minus b is negative a, or I'm sorry, b minus a, which is what we did above. And I could say 4 minus x squared is negative x squared minus 4. And that's how you switch the order. That's the opposite of the polynomial. And if you want to verify, you can distribute the negative, and you'll get what you started, because negative x squared plus 4, which is 4 minus x squared. So we're going to revisit that later, but I figured it'd be a good point or a good time to point that out now.